Okay, this is a problem that covers the concepts of even and odd functions. And this is something we're going to talk about all year long, whether we're doing algebra, trigonometry, you name it. So I'm going to cover, first of all, the definitions of what even and odd mean, and then 3 examples, which I've numbered 1, 2, 3 on the left. Now, speaking about what even odd mean, look what I've done here. This is an equation for an even function. If an even function satisfies this equation, that's why it's called even. So here's the distinction. If you can put in a negative number in for x, and the result is the same as if you had put in a positive number for x, in other words, it doesn't matter if you put in -2 or +2, -5 or +5, it gives you the same result either way, that's an even function. And graphically, you can think of it as something that looks like this. Imagine a parabola. Okay, I've got a parabola right here. This is called even because whether I put in x equals 3 or x equals -3, I get the same result, y equals 0. That's an even function. It's symmetric about the y-axis. Okay, so an odd function is the opposite. If you put in a negative right here for x, what you'll get out is the opposite function. So if I put in -5, it'll give me the exact opposite result as if I had put in +5. Let me show you what an odd function would look like in a graph. Remember x cubed? Looks like this. If you put in x equals 3, let's say right there, and x3 gives you a certain result for y, okay, let's say 9. This isn't really to scale, but don't worry. Now, what if I had put in x equals -3? Well, what you get is -9. Down here, you see that's the opposite of +9. So that's an example of an odd function. And there are all sorts of even and odd functions. We're going to go through how you calculate them algebraically. And for each one of these 1, 2, 3 examples on the left, I want to show you a shortcut for how you find this quicker. Because if you can just look at a function and say, oh, that's odd, or that's even, that's a lot quicker than plugging in numbers. So let's start with number 1. Number 1 says 3x cubed minus x plus 1. So here's what I'm going to do first. I'm going to plug in -x and see what happens. Okay, so let's try this. F of -x, according to the number 1 equation, equals 3 times -x cubed minus -x plus 1. Okay, now we work through the algebra. -x cubed is, well, negative times negative times negative. That's still going to be a negative. And then x cubed is just x cubed. So I have -x cubed with the exponent now inside the parentheses. Minus -x, what's that? That's going to be +x. And then I have my plus 1 right here. And we keep working through it. Distribute those negatives on the left. I think that's the hardest job with this stuff, distributing negatives. We get this as the result. Well, compare it to what you started with. What we started with was f of x equals, where are we here? 3x cubed minus x plus 1. And if you look at the things, the signs now, what do we have here? That's odd, because the sign has changed from negative to positive. That's odd, because that sign has changed from negative to positive. Uh-oh, look at this. This sign did not change. So we have an equation here with both even and odd elements in it, which means it is neither even or odd. To be odd, you have to be odd all the way. You can't just be a little odd. And to be even, you have to be even all the way. So that's how we found out that in this example, number 1, the result is neither. It is neither even nor odd. Now here's the quicker way. I'm going to circle things in blue when I think they're odd, and I'm going to circle them in red when I think they're even. I see an odd right there, I see an odd right here, and I see an even right here. That's the quick way. You look at that, you say, oh, it's a mix of even and odd, so it's not going to be either. Let's do number 2 next. Now, this shortcut is a little bit of a hand-wavy thing, so I might change how it works a little bit for each one of these. In number 2, I'm going to say, okay, f of -x equals, and now watch what I do with this equation. 7 times -x divided by negative, and now I put a negative x inside the squared term. And I still have that plus 7. Okay, now you might think it's going to be the same as the last result, but hold on, it's not. Watch what happens. Negative x times 7 on the top gives you negative 7x. And on the bottom, look what we get here. You have negative. What's negative x times negative x? Well, see, that's going to turn into just a positive x squared plus 7. And once I simplify everything and I get rid of all the parentheses, look at what we have. Negative x squared plus 7. Okay? So if you compare what we started with, that's always the most important thing. F of x with no negatives. That was just 7x negative x squared plus 7. So, question is, are these two things opposites? When you compare this over here against this one, are they opposites or are they exactly the same? Well, I think they're opposite. Even though the bottom is the same in both cases, they're opposite in the same sense that if I compare 3/4, how does that compare against negative 3/4? See how those are opposites? You don't need the opposite sign both top and bottom. You just need it on the top because I'm comparing 3/4 to negative 3/4 in this example. Or, for our equation, I'm comparing 7x over a denominator to negative 7x over the denominator. See, the denominator is the same. What I'm comparing is the top, 7x versus negative 7x. So in this case, this guy, number 2, was odd. And here's the shortcut. Here's how I look at it fast. I say, oh, the numerator is odd, but take a look at the denominator. That is even. And when you divide an odd number by an even number, you will always get something that is odd. Okay? Last one. And this may catch some of you. This may trick you. In this example, I'm pretty sure you could just go through this by yourselves and plug in negative x. So I'm going to skip the slow part, and let's just skip right to the quick part here. 7x is odd. If I plug in a negative, I do get negative 7x. Okay, that's clearly odd. On the bottom, these are both odds also. 5x cubed is odd, 4x is odd. Notice how the exponents are odd? When the exponents are things like 3 and 1, then you know the function is odd. Whereas if the function had a mix of exponents, like this exponent was 3, that one was 2, this one was 1, that would be neither because it would be a mix, even and odd. So in this one, I'm dividing odd by odd. Now what happens if you divide an odd number by an odd number? Okay, you're going to get, actually even odd integers are not a great example, but for example, if you divide a negative sign by a negative sign, you would get a positive. And in this case, if you divide an odd function by an odd function, you will get an even function. Let me prove it with a little bit more explanation. In number 3, I have 7x divided by, what was this, 5x cubed plus 4x? 5x cubed plus 4x. Here's another way of thinking about it. It's not just odd divided by odd, which makes even. You could also think about it as this. What if I cross out a factor of x? Okay, see, first I factor out x, and then I cross out those x's. Like that. Well, what's left? This is going to be 7, which is an even function, right? 7 doesn't care if x is positive or negative. I know you're thinking 7 is an odd number, but in this case, it's an even function. And on the bottom, 5x squared plus 4 is also an even function because x squared is the same as, well, it's hard to say it, but it's the same as negative x in a parentheses and then squared, right? It doesn't matter which one it is. So in this case, I have shown that I can simplify odd over odd to even over even. That's why this number 3 example was an even function.